Hi everyone. So the purpose of this video is to understand acceleration. Make sure you have your guided notes as you are watching this video. Our learning targets are to recall the definition of acceleration and to be able to calculate acceleration. So every now and then I leave a quick little preview of what the video is going to talk about. I'll just kind of skip over this, but if you ever want to take a look at maybe what you should be putting in your notes, what the basic idea of the video is going to be, I usually have this slide in there. All right, so let's just do a quick review. We have displacement. That's how far an object moves, or more specifically, how far does it go from where it started to where it ended? Okay, so I think we can all imagine situations where somebody runs from one place to another, a ball is thrown from one place to another, whatever your interest is. And then velocity is how fast the object is moving. Again, we can think about a track runner, how fast are they going, right? For football players, we want to know how fast, typically how fast can they run a 40-yard dash. Track runners, typically, a typical race is a 100-meter dash. How fast can they do that? Rockets, planes, whatever, we can track their velocity if we know their displacement and how long it took them. So that's great, but what if that object is speeding up? Or what if the object is slowing down? Their velocity is changing. And so what do we call that? Well, we call that acceleration. And so acceleration is the change in velocity divided by the change in time. So we want to know how much did the velocity change and how long did it take for that velocity to change. A common example that some people might be interested in is, the acceleration of a runner. How quickly can they go from the starting line to their top speed? And sometimes coaches will work with athletes to really work on the first few steps of their sprint to really work on their acceleration. Or if you're interested in cars, common measurement for cars is how fast can they go from 0 to 60? How long does it take them to go from 0 miles per hour to 60 miles per hour? And there's an example that I'll show you later on in this video. All right, here's the equation that we can use. So just like velocity, velocity has a very similar setup. So let's talk a little bit about this equation. Acceleration is final velocity minus initial velocity divided by the change in time. And so another way to say that is that we have some change in velocity divided by the change in time. That's what acceleration is, and that's how you would want to calculate it. Just a few reminders about some of the terms that we've been using. Displacement, velocity, acceleration. They're all vectors. That means that they have a direction. They can be negative or positive, and they can be drawn as a vector. And remember, a vector is just a line with an arrow. So if I was going to draw a vector right here, right, I could say I have some kind of acceleration in this direction, right? That's a vector, and I can draw acceleration as a vector. If my acceleration is small, I might draw a little arrow. If my acceleration is big, I would draw a big arrow. All right, but that's just what a vector is. So here's another example of vectors, and let's talk about some different situations where velocity and acceleration are going to be analyzed carefully. So let's look at this first picture here. This car moves at a constant velocity. That means there's zero acceleration. And that's what we've kind of been looking at for the first, the first 2 days about talking about velocity. We're really just talking about something that has some kind of constant velocity. So in this case, the car is just moving along at a constant velocity. Notice that the velocity arrows, the velocity vectors, are the same size every step. Now let's look at a situation like this. This car has a constant acceleration in the direction of its velocity. So what this picture is showing, it's kind of like taking a snapshot of the car every second. And so what you're seeing is at first the velocity is low. Oops, let's go back. At first the velocity is low, but there's some acceleration. That means that the car is accelerating. It's like the driver is pushing on the gas pedal. And as they're accelerating, the velocity is going to get bigger and bigger and bigger. And also, as you can imagine, if the car is speeding up, they are going to be able to cover a bigger and bigger distance. So the distance or the displacement that the car is covering every second is getting bigger and bigger. So the velocity is getting bigger because the car is accelerating. All right, last example that I'll show. This car has a constant acceleration in the direction opposite to its velocity. So what does that really mean? That means that the car is moving maybe in the positive direction, but the acceleration is negative. Maybe think for a second, what would that mean? What would that look like for a driver? So in this first example, we can imagine that the driver is pushing on the gas pedal to make the car accelerate. If the car was moving forward, but we wanted to slow down, we would just hit the brakes. And that's really what is happening in this picture. The car is moving forward, but the acceleration is in the negative direction. That just means that the car is going to be slowing down. So we can see that the velocity vector is getting smaller and smaller and smaller and smaller. So I hope we can try to relate what's happening with some of the physics terms like vectors and direction with what we already kind of know about driving, right? If we're hitting the accelerator, we're going to be getting faster. Our velocity is increasing. If we hit the brake, that means that our velocity will get lower and lower, and maybe we'll reach a stopping point where the object will stop. So I hope we can kind of connect those two ideas that we're seeing here. All right, worked example that I'll show you. So like I said, 0 to 60 is a common measurement for cars. Let's take a look at that, but we're going to use some of our physics terms that include meters per second. So let's work through this problem. So we have one model of a Ferrari, and there's many different Ferrari types out there, but Ferrari is kind of known for having some very fast cars. Can accelerate from 0 miles per hour, which is 0 meters per second, to 60 miles per hour, which is 27 meters per second, in 2.5 seconds. What is the Ferrari's acceleration? Okay, so I've read the question carefully. I could read it again. One model Ferrari can accelerate 0 miles per second. Make sure I underline my variables. I have this one that's important, this one, and this one. All right, because I have meters per second, I have seconds. All right, so now I want to make sure I have some kind of model. So this car is starting here. Its velocity is in this direction. Actually, let's take that back. Let's just erase everything I put. So let's make sure I underline this again. All right. So its velocity at first is 0, but then over time, the velocity is going to get bigger and bigger and bigger. So this is one way I could draw this model. I can try to draw my velocity vectors, right? And then I also know that my car is accelerating. So I have some kind of like acceleration vector that I could draw. So I know that the acceleration and the velocity are in the same direction. Okay, let's think about what my units are here. So I know that I have a velocity, I have an initial velocity of 0. That's easy. I have a final velocity. Sorry if my handwriting isn't very good on this computer. I'm clicking on things and it's kind of hard. My final velocity is 27. All right, and then my time, it's a triangle. Time is equal to 2.5. So if you have the equation written down on your notes, you can see that what I'm supposed to do here for my acceleration is my unknown. So let me just write that down here. Acceleration is question mark. Okay, so acceleration is going to be final velocity minus initial velocity divided by my change in time. All right, kind of running out of room here on my screen. I'll try to do it up here. So we have final velocity of 27 minus 0. 0 is my initial velocity, divided by 2.5. All right, this ends up being 27 minus 0, so that's just 27. And then 27 divided by 2.5. So my acceleration is going to be equal to, I'm going to need a calculator for this one, 27 divided by 2.5 is 10.8. And then here's the last thing that's pretty important about this. We have a velocity. Velocity is measured in meters per second. So these numbers are meters per second. So this is meters per second, but we're dividing it by time again. So we have meters, it's kind of like saying meters per second, meters per second, which is kind of a funny phrase, but so sometimes what we'll say is meters per second, or we might say meters per second squared. It's kind of like we're dividing by time twice, which means we call it meters per second squared. Those are your units for acceleration. Make sure you include your units when you're doing any practice problems. All right, you probably have some practice problems next once you finish the notes, so good luck with that.